Hello everyone, I am Dr. Mian Shafiq, Assistant Professor from Nazarbayev University, Kazakhstan. The topic of my presentation today is application of machine learning in petroleum engineering, unlocking data-driven innovations in oil and gas industry. So, first of all, I want to introduce about machine learning. So, machine learning is a domain of artificial intelligence, AI, and it is used for learning algorithm, find patterns in the input data to create a model that can reproduce the data. Why it is important in petroleum industry and what is its role in the growing decision making data. So it is important because petroleum industry, everything is done based on assumptions. We cannot see anything clearly what is happening in the reservoir. So we have to go through a lot of parameters, and based on those parameters, on those analogs, on data, we need to make a decision. So machine learning is very important for oil and gas industry because machine learning, what it will do, it will get input from you, and from that input, it is going to generate the models. So these models generated by machine learning will be very helpful in the decision making because uh, in the coming future, one of the main thing in the world will be the finance. Okay, because oil and gas industry is very big, and we have to spend millions or billions of dollars for the development of field. We have to invest a lot of money. So by incorporating machine learning in oil and gas industry, the data decision will become more easier, will become more economical, and less time consuming. So let's discuss about this. Maybe if you are confused about artificial intelligence and machine learning, so machine learning is a part of artificial intelligence. And within machine learning, you can have a deep learning also. In deep learning, you can combine different machine learning programs even. So artificial intelligence is a broader way. Then you have a machine learning, which is a part of artificial intelligence. Then you have data mining, in which you have to clean your data and you mine your data. Then you have neural networks, like we have artificial neural networks, physics-induced neural networks, and then you have deep learning. So there's something about literature, like artificial is a bigger prospect, while machine learning is a part of that artificial intelligence. So background of incorporating machine learning in petroleum engineering, because the reservoirs are complex. Complex means they have different minerals present inside, uh, high pressures, high temperatures, and drilling cost will be very high. Even the operational cost will be very high. Production optimization cost will be very high. Then you have to apply different methods like artificial intelligence, enhanced oil recovery. So these methods will be very expensive, costly, and one of the most important is the safety of data and explosion from sensors, logging data, because we have to go for logging, coding to find out different parameters. So while you are doing these data explosion or you are doing this logging, so what is happening? You are getting a lot of parameters. So based on those parameters, you have to take the decision. So if you take the decision from the machine learning models, which can predict very good or accurate uh, output, so it will be easier for you to make a decision. Okay, these are challenges. You have to incorporate complex reservoirs, cost, safety, logging, and simulation. Simulation is basically the modeling in which you simulate the reservoir and you create a reservoir model. Machine learning enables data-driven insights and optimization. So what ML can do, what machine learning can do? Because machine learning has the ability to analyze large data sets. It has the ability to identify different patterns, okay, and make predictions in transforming the industry. It can make predictions like if you input these parameters, if you input these things, what will be the outcome of that based on different studies available today. So machine learning is increasingly becoming a vital tool in petroleum engineering, offering solutions for complex problems in exploration, development, and production. Means machine learning is applied in all the fields of oil and gas industry. Now, if you go for more details, what is the role of ML in oil and gas industries, in gas companies? G&G, geology and geophysics. This is the essential part of oil and gas industry from where we start the exploration. So geological engineer and geophysicists or geoscientists, they are basically responsible for the exploration, initial phases of your reservoir, then initial phases of your drilling. Then you have PE, petroleum engineer, RE, reservoir engineer. So this ML is very important, means machine learning is very important for all of these engineers because geological engineers they have to make a data. The data or they have to make a model, 3D model of what your reservoir or how your rocks looks from inside. That is the role of geological and geophysics engineer. Then you have a PE engineer, petroleum engineer, which has a role to drill, okay, which has a role to drill and to produce. So based on G&G, the drilling engineer makes the decision that whether they have to go for drilling or not. So based on those parameters, your petroleum engineer or production engineer, they can, or drilling engineer, they can make a decision whether they have to go for this drilling or not. Then you have a reservoir engineer. So reservoir engineer, RE, the role of reservoir engineer is to make a decision whether your reservoir is economical or not. So once you do exploration, you drill, then you start production. The role of reservoir engineer is to see whether your reservoir is going to produce for a long time or not, and that is also very important. What kind of optimization techniques we have to apply? What is the role of optimization techniques applied so far? So based on that data, reservoir engineer can make a decision that how your reservoir is going to perform in future. So this is the role of machine learning in oil and gas companies. So when it applies to oil and gas industry, so what it can do for you? For example, in case of drilling, it can reduce your drilling time because you already know that if you are drilling specific type of formation or if you are drilling a specific type of reservoir, how your drilling can be done based on the studies or the model prepared by machine learning. It can classify drilling events. Drilling events means you have to go for directional well, you have to go for horizontal well, you have to go for multilateral well, how you have to go. So that is basically already modeled by machine learning. Then kick detection. Kick is very important to control the blowout of the well. So do you know about very important or very famous incident of oil and gas industry, which is Deepwater Horizon? What happened? They were not able to control the kick. So if you and because of the blowout, the company have to lose millions or billions of dollars. So if you can detect a kick, or you can predict a pipe stuck, that your pipe is stuck and what type of fishing operation you have to do, how you can remove that pipe, or maybe you can detect low circulation or you can detect other problems within the drilling. So it can reduce lot of cost of your drilling. Then GNG, geological and geophysics, because you are going to get seismic data. So machine learning can interpolate the seismic data, and it can create the plots. It can detect where there are faults in the reservoir. It can do fault interpretation, petrophysical modeling, like what kind of what are properties, or what is the permeability, porosity, resistivity of your reservoir, and facies classification, like what type of animal remains are in your reservoir. From that animal remains, or by doing correlation, you can find from which era or from which time period your reservoir belongs to, your rock belongs to. Then for the course of for the reservoir engineer, you can have a production forecast. As I mentioned, the role of reservoir engineer is to see like how long your well can be produced. So it can forecast the production, it can predict that how long your well can be produced, and what can be the production rate. And it can also assist in history matching, which is very important part of your reservoir simulation. For production, it can predict well performance, how your well is going to degrade, how your uh, pressure is going to be degraded or reduced with time. It can predict the failure of your well, that whether your well can be failed at any time. So we have to make proper decisions to avoid this. Lift performance, like what type of artificial lift method you have to apply here, so that your reservoir can be produced for longer time. Then applications of machine learning, as I said. So we see like drilling optimization. It is used to optimize drilling operations by predicting critical parameters like what type of horizontal stress you are going to face, okay, through recurrent neural networks. The workflow for predicting minimum horizontal stress using machine learning models is illustrated. Okay, so I'm going to show you a picture starting from data collection and revision through model training and evaluation to the selection of the most suitable model. So it can interpret real-time data, it can interpret the rear of the drill, and uh, rate of penetration optimization. So you see this example. So this is your drilling well. Okay, what we do, we took 11,000 data points for training and 2,000, almost 2,800 data points for test. Okay, so what we input here, we input depth, that what is the depth of your reservoir. We input what is the pore pressure on the reservoir, what is the Poisson's ratio, and what is Young's modulus, compressive UCS, compressive strength, and density of the formation. So we put everything, okay, and what is the output? Minimum horizontal stress. That what can be the minimum horizontal stress in case of if we put these inputs. The ML model can be used RNN, LSTM, and GRU, and trained models can be trained RNN, trained LSTM, and trained GRU. And then we have the algorithms like RMSE, R square, ME, MAE. So based on these models and these results analyses, these algorithms, we can make a robust model. We can make, first of all, we select that which model is performing well in case of this, and then we can make a most robust model based on these inputs, that what can be your minimum horizontal stress. So if you know this minimum horizontal stress at some specific depth and pore pressure, it's easier for you to drill that section, because you already know from the model that how your rock is going to behave. Then application in reservoir characterization. It is UMR algorithms are used to predict reservoir properties such as porosity and permeability, very important parameters of oil and gas rock sample. For example, drilling parameters can be integrated with machine learning tools to predict real-time porosity in multi-zone reservoirs. A flow chart illustrates this process, starting from petroleum geological formation identification to model validation for predicting rock porosity. You see here, this is your petroleum geological formation. Okay, so you have reservoir, temperature of the reservoir, then you have RDC reservoir, and then you have QH reservoir. 3 types of reservoir, and then you have to get the data. Okay, so this is the software which is used to get the data. And what type of inputs you have? You have what is the depth of your bit, what is the rate of penetration, what is the weight on your bit, rotations per minute, temperature, flow rate, and static pressure. So you put all these inputs to machine learning model, okay, to machine learning model, and what you want to get? You want to get the rock porosity from these data. So it means like from 80% training data, 20% validation we use, okay, and for reservoir we have T1 reservoir, RDC reservoir, and QH reservoir. And from different reservoirs, we put this data, we get this data, and the output will be the rock porosity. So if you create a model, and then anytime in future, if you put these type of parameters, or if you're going to experience these type of parameters, your model is going to predict that what kind of porosity or what is the value of porosity at that time. And then what you're going to do, you're going to do the validation. How you're going to do the validation? It's like you have two machine learning models, and when you create the machine learning models, what you do, model validation, you again do algorithm like RMSE, MEA, and R-square. So you do this algorithm validation, and you will reach your model end. So that's another example of machine learning application in petroleum engineering. So you can predict rock and fluid property, okay, like porosity, permeability, and the fluid property like interfacial tension or wettability or interfacial tension. Speed up of reservoir simulation. So you can speed up your reservoir simulation process if you have this model, and you can do the history matching and production optimization. So application of machine learning, like we can do seismic data analysis. So artificial driven seismic imaging and data analysis techniques enhance the efficiency of oil and gas exploration, as I mentioned earlier. Okay, so machine learning models interpret seismic data to predict subsurface structures and identify potential hydrocarbon reservoirs. Yes, one of the most important technique here is enhanced oil recovery. So machine learning techniques are used in CO2 EOR projects. CO2 means carbon dioxide enhanced oil recovery projects to predict minimum visible pressure, optimize well locations, and predict oil production and recovery factors. So machine learning also assists in predicting the performance of nanoparticle-based enhanced oil recovery. So enhanced oil recovery process can be optimized using machine learning applications in petroleum industry, and this is very important because EOR is very expensive procedure. So predictive maintenance ML machine learning is used to predict equipment failure, reduce downtime, and improve operational efficiency in the oil and gas industry by analyzing sensor data and historical maintenance records. Machine learning algorithms can identify pattern and predict when equipment is likely to fail, allowing for proactive maintenance. So you can even maintain your field or maintain your instruments based on the data by machine learning. And it can also forecast the production and optimization. Okay, as I said, machine learning algorithms forecast oil and gas production rates. It can specifically optimize water flooding strategies and enhance oil recovery process. For example, hybrid artificial intelligence methods optimize water flooding by considering multiple objectives and coordinating various well control parameters. So feature important scores of geological and operational parameters in a petroleum engineering context are presented in a bar chart, highlighting the significant impact of operational parameters such as liquid production rate and water injection rate. So how much water you are going to inject and how much oil you are going to produce, that can be predicted by the help of machine learning. Additionally, machine learning can predict the critical total drawdown in sand production from gas wells, which is essential in preventing the sand production. So machine learning can also prevent the sand production. So you can even estimate the bubble point from other parameters. For example, you have temperature, you have gas oil ratio, you have gas gravity, you have the API density of the fluid. So based on these parameters, you can predict the bubble point pressure of the reservoir. So how it is the workflow of machine learning is very simple. For this bubble point pressure, what you have to do to consider the relationship between bubble point pressure and crude oil with its RS, oil API, gas gravity and temperature. Imagine you have a 250 sets of data are available from light oil collected from the Middle East and Africa. 70% of data here, like 175 rows, are randomly selected to train the model, and 30% are used for the testing of the model. So the learning algorithm find patterns in feature like the learning algorithms. What they can do, they can find pattern or relationship between temperature, RS, gas gravity, and API to create a model that can predict the bubble point pressure. The model is then tested by remaining 30% of data to validate its predictions. What we do, why we have training and testing. For training, we train the model, and from model, after that, from remaining data, we test whether our model is trained or not. So see, if you see here, we have linear regression, we have random forest, we have XGBoost, and we have neural network. So they are different machine learning models. And if you see here, the neural network show more than 90% accuracy from testing. It means it 90% accurately measured your bubble point pressure using the data. So what is integrated with physics-based models? So physics-informed machine learning models, PML, integrates physics laws and engineering principles into ML models. This approach enhances the accuracy and reliability of the models, especially in subsurface flow patterns. Residual enhanced physics criteria machine learning with hard constraints improves the understanding of oil field development and predict residual oil calculations. So what are the challenges and future trends? So data quality and availability, the performance of ML models heavily relies on the quality and quantity of data. Data-driven intelligence approaches require large data sets. So you have to have large data sets to get the good results. And then you have model interpretability. ML models are often considered as black box simulations, making it difficult to understand their decision-making process. Combining ML with first principles models can improve the explainability of data-driven models. Integration of AL and process mechanism. Integrating AL algorithms with process mechanism enhances the understanding of hybrid modeling techniques and optimize chemical processes. So, a universal framework integrates AL algorithms and process mechanism to enhance chemical processes. Molecular modeling. Machine learning assists molecular modeling in understand fluid transport properties in unconventional reservoirs. So it has also played an important role in unconventional oil and gas industry by forecasting production and hydraulic fracturing optimization. The advancement of AI drives technological progress and industrial upgrading in unconventional reservoirs. So in conclusion, I can say machine learning is revolutionizing the petroleum industry by improving efficiency, reducing cost, and enhancing the decision making. As the industry continues to generate vast amount of data, the application of ML will only expand, driving further innovations and optimization across all aspects of petroleum engineering. Thank you for listening.